In this video, we have given that a 20-gram bullet pierces through a punnet of mass m1 is equal to 1 kg and then comes to rest inside the second punnet of mass m2 is equal to 2.98 kg as shown in the figure. It is found that the two punnets initially at rest now move with equal velocities. Then we have to find the percentage loss in the initial velocity of the bullet when it is between m1 and m2. And also we have to neglect any loss of material of the punnet due to the action of bullet. So here we have a punnet of mass m1 and in another punnet of mass m2, and both the punnet are in rest. That means velocity of both punnet is 0, and a bullet of mass s1m and velocity is u. And in case 2, this is the punnet of mass m1 and the bullet is piercing punnet 1. The bullet has come here and mass is m, and the velocity of bullet is decreased from u to some u1, and the velocity of punnet 1 has increased from 0 to v, and this is punnet 2 of mass m2 and the velocity of punnet 2 is still 0, and in case 3 this is the punnet of mass m1, velocity is v, and this is the punnet of mass m2 and the bullet is in punnet 2, mass is m, and the velocity of punnet 2 is v. And we have given m is equal to 20 gram. That means it is 20 by 1000 kg, and 1 0 will get cancelled and it is 0.02 kg. And also we have given m1 is equal to 1 kg and m2 is equal to 2.98 kg. And we have to find percentage change in velocity from case 1 to case 2. So it will be equal to change in velocity by initial velocity into 100, and change in velocity is u minus u1. It is u minus u1 by initial velocity is u into 100. So we have to find the value of this. So we can use momentum conservation between case 1 and case 3. We can use momentum conservation in case 1st and case 3rd. So in case 1, a small m is moving with velocity u, and in case 3rd, m1 is moving with velocity v, and m2 plus m is moving with velocity v. It will be equal to m times u is equal to m1 times v plus m2 plus m times V, and m is 0.02 kg, U is equal to m1 is 1 times V plus m2 is 2.98 plus small m is 0.02 times V, and it is 0.02 U is equal to V plus 3V, and it is 2 by 100 U is equal to 4V, or U will be equal to 400 by 2, that will be 200V. Suppose this is equation 1. And we can also use momentum conservation. In case 1 and case 2, here in case 1 a small m is moving with velocity u, and in case 2 m1 is moving with velocity v and m is moving with velocity u1. It will be m times u is equal to m1 times v plus small m times u1, and m is 0.02 kg times u is equal to m1 is 1 times v plus m is 0.02 u1, and it is 0.02 u minus 0.02 u1 is equal to v, and we can take 0.02 common, and it is u minus u1 is equal to v, or it is 2 by 100 times u minus u1 is equal to v, or it is u minus u1 is equal to 100 by 2 will be 50V. Suppose this is equation 2. And we have to find the value of u minus u1 by u into 100, and u minus u1 is 50V by, and u is 200V. U is 200V into 100, and 50V times 4 is 200V, and 4 times 25 is 100. So it is equal to 25%. So percentage change is 25%.